Hi, good afternoon, everyone, and welcome to the May edition of the European Membrane Society webinars. I am Maria Grazia De Angelis, and on behalf of the European Membrane Society Council, and with the support of Professor Marco Stoller and Dr. Elena Tocci, I am going to present today's webinar. I am delighted to introduce you to one young researcher from our community. Her name is Dr. Rhea Verbeke. I'm sorry to mispronounce your name. And she's going to talk us today about a very nice initiative she has been promoting with some colleagues. That is an open membrane database regarding reverse osmosis membranes. Such initiative was founded by an international team of researchers from KU11, Hong Kong University, Yale University, and Technion Israel Institute of Technology. Rhea she got her Bachelor and Master of Science degree at the Faculty of Bioscience Engineering at KU11 in Belgium. She then pursued a PhD in the same university. With many research stays abroad, both in academic and industrial research laboratories. She is expert in the characterization of membranes, and in particular the characterization of depth-dependent elemental composition and free volume of desalination membranes. And she developed epoxide chemistry as a novel platform for the synthesis of chemically robust membranes. Currently, she is still employed at KU11, but she is a visiting postdoctoral researcher in Mainz, Germany. And in today's webinar, she is going to talk us about the functionality of the database. This database contains data about 650 desalination membranes, and it enables you to actually upload your data and contribute to the database yourself. So now I leave the stage to her and enjoy the presentation.
So hello everyone, thank you all for being here. Also, thank you very much to the European Membrane Society for the opportunity to showcase the OMD here today. So as you can see from the first slide already, there are many people involved in this initiative, and I would like to thank them all once again, because without their help, this would have not been possible. So what is the Open Membrane Database? Let me just click this away. So the Open Membrane Database is actually an archive or a library of the membrane performance and characterization data, especially for reverse osmosis membranes. So we use reverse osmosis technology as an example, as a pilot database, because it's such an established technique. We currently have been working on this now since the end of, or let's say, mid 2020. Yeah, and currently there are 650 membranes uploaded. And then we launched the database in August 2021, so about 9 months ago. And since then we have quite some visitors every month, so about 300 every month. So if you want to have the URL of the database, it's just openmembranedatabase.org. I would highly appreciate if you could stay with me for this presentation, because I will actually give you a tour on the website itself during this presentation a bit later on. So which topics will I cover today? So first I want to talk a bit very briefly actually about the state of the art of membrane desalinations, which membranes are used, and yeah, just what the state of the art is. Then why do we actually need a database? Is it actually useful for the community to have one? And I hope that I can convince you that the answer is yes after this talk. Then I want to introduce you to the OMD team, really an incredible team that has worked on this very hard to make it possible. Then I want to give you some more information on the data that we need for the OMD and the constraints that we actually have decided to put so we could actually make a database. Sometimes you need to make decisions to push projects forward. And so I want to share these with you as well. Then I will demonstrate the website to you. I will give you a brief tour, show you what we can do on the website itself, also the calculators that we've recently introduced, so you can use them for your own research. And then I would like to conclude with a brief outlook on what we're planning on doing with the OMD. So currently expanding the reverse osmosis one and then also extending the OMD to other membrane technologies. So let's start with the introductions. So reverse osmosis membranes, they can help us to combat the global water crisis. It's really, I think, one of the biggest challenges of the 21st century. We are feeling it every day more and more. And it's actually because the demand for water has largely exceeded the supply, both in terms of quantity and of water quality. That is also why it's one of the Sustainable Development Goals of the United Nations. We have to ensure the availability of clean water for the current generations and also for the future generations. It's pretty obvious that without water there is no life, but it seems that we are kind of missing out on some crucial things to actually preserve that and to ensure the availability. So which technologies could help us combat the global water crisis? Well, that is then desalination of river water and seawater, so unconventional water sources. We can do that with reverse osmosis membranes. We can also do that with thermal technologies. And thanks to the lower energy consumption of reverse osmosis, it has received increased attention, and also now it's about 70% of the water that is produced from river and seawater is via RO, while only 30% is via thermal technologies such as MED and MSF. There are about 6,000 desalination plants right now located in 177 countries, which is quite a lot. But out of these 177 countries, 40% of the desalination plants are actually located in the Middle Eastern world and also in North Africa. And also from an academic point of view, we can see that there's actually still a huge increase in publications on reverse osmosis desalination membranes. So the technology was developed in 1970s, and it has increased and gained in attention up until actually 2020, and the curve is still going on. So which membranes are then used for reverse osmosis desalination? What's actually polyamide membranes, which have a thin film composite structure. So what do I mean with that? It's actually a porous support layer, which is providing the mechanical support to a thin and dense top layer. And it is this dense polyamide top layer that is doing the actual separation. So it's allowing water to pass while selectively rejecting salts. This dense top layer is made via interfacial polymerization. Often it is, or actually always, it is a polyamide layer made from the reaction between triacyl chloride and diamine. The big advantage of this technology is its excellent water salt selectivity, and that is thanks to the thin and dense structure of the interfacially polymerized polyamide. How do we describe reverse osmosis performance? Just very briefly. So we do that with the solution diffusion model. We have the water flux, and then we also have the salt flux that characterize the reverse osmosis membrane. However, it's actually better to talk in terms of A and B parameters, so the water permeability coefficient and the solute permeability coefficient, because these are intrinsic membrane properties. They are not so dependent on the operational conditions, and so it helps us to use these parameters, A and B, to actually compare membranes that were tested under different conditions. I'm telling you this because also for the reverse osmosis database, that is actually really important, an important point, and I will come back to this later on. What is very interesting to me and what actually shocked me when I was still doing my PhD a couple of years ago is that there have only been marginal improvements in reverse osmosis performance in the last 30 years actually. So I'm plotting here the water salt selectivity A over B as a function of A. So this is what we call a typical trade-off plot or an upper bound plot. And there you see that some improvements have been made, but there has been no breakthrough, at least in the past 30 years. that is really shocking to me, and maybe also to all of you, I don't know. But that is probably because the membrane is still largely seen as a black box, so we don't really know what is happening inside. We still don't really know how they're functioning. We're figuring it out. Yeah, right now, but we still don't really know. And so if we want to optimize a membrane for a certain application, or if we want to selectively optimize them for a specific property, then we actually need to undergo a full trial and error approach, which is very time inefficient and um, inefficient also in the materials we're using. It just as a whole very inefficient. And another thing that is closely related to that is that we don't fully understand the membrane synthesis structure performance relationship of these membranes. So the synthesis conditions, how do these influence the membrane structure, and how does the membrane structure then in the end influence the membrane performance? So why do we then need a database? What is the link between the two? Yeah, well, actually, I started thinking about a database because of some frustrations I was having during my PhD. As I just mentioned, I just could not understand that the field, after so many bright people have been working in it, so many research has been done, that we still didn't understand how this kind of mature technology right now is working. I think that's really something fascinating. And so I was, yeah, I just I thought it was so amazing. These membranes are producing liters and liters of water every day, and still we don't understand how they actually work. And then another point I thought was really frustrating, or that we could improve during my PhD, was that it was so hard to actually find the data in literature. So if you wanted to find the data from a certain article, or if you wanted to compare your own membrane data to data in literature, then it's always so hard to find the raw data, because often they're just plotted in a certain way that you don't have the exact number, or then the membranes were tested in a different way, so you couldn't compare them with your membranes. And then I thought, yeah, what can we do about this? So I was talking about yeah, these frustrations, and just like with the hope I was having to improve this with one of my colleagues who was actually in the MOF field, so metal organic frameworks field, and he said like, oh yeah, maybe a database would be a good idea, because we have one in our field. So he was talking back then about the Cambridge Structural Database, which is also which includes the Metal Organic Framework Explorer, and this database was already online in the 1960s, or they started working on it in the 1960s. And then I started looking into it a bit more. It was very interactive, a crazy amount of structures that were uploaded there and that were reviewed by a panel. Then started looking into other databases, and then we also have the data bank of proteins, so the structure of proteins, which is also already more than 50 years old. And I thought, how is it possible that we don't have such a database? So then, yeah, if it's not there yet, then I thought, why not create it? And then we started engineering it. And we found it on the following principles. So what was really important for us is that it was free and open access. I really wanted to be open access for everyone around the globe, should be free, no one should pay for it, and also no registration is needed. Secondly, I wanted to be a project that is sourced by our own community, so by all the membrane researchers around the world, that they can just input their own data and make the database grow. For the credibility of the data, we decided to only use membrane performance data from peer-reviewed journals, so that we have the peer reviewing progress that is actually providing the credibility of the data. And then also we wanted to bridge the gap between academia and industry, so we also decided to include membrane data from patents and also from commercial product data sheets. Fourthly, I thought it was also, I also saw the opportunity as the OMD as an opportunity to unify membrane reporting. So many labs around the world are testing their membranes in a different way. We don't really have a gold standard for it. And I thought it would be good if we could like also try to incorporate that in the OMD itself. And then I'm a big fan of international research days, as you can see from my journey so far, and just yeah, interdisciplinary research. So I also wanted the OMD to be founded on an international mindset, and that is why I put together a team of researchers from different parts of the world. So who are we then? Who is the OMD team? So we have the two founders. I co-founded this with Timothée Stassin, also from KU Leuven. So he's a person who worked on MOFs. And then I gathered together the amazing list here of founding members. I actually want to go through all of them one by one because they really did an amazing job with gathering all the data and uploading it to the database. So Cody, Doug, and Ryan, who were all at Yale when I was at Yale during my PhD. Then we have Ines from the lab, from my lab in Leuven, and then also Dr. Tse Yang from Hong Kong University, who actually published a very important review on the upper bound of reverse osmosis a couple of years ago. So I also really wanted him on board. And then we have two researchers from Technion University, Adi and Nama, under the supervision of Guy Ramon. And so the whole OMD was actually funded by 4 professors. So my professor in Leuven, Ivo van Kelekom, Chu Yang Tang from Hong Kong University, Menachem Elimelech from Yale, and then Guy Ramon, as I mentioned before, from Technion University. Then, of course, we are all membrane researchers. We're all in the membrane field, so we were not able to build a whole website. So that is why we collaborated with the web developers from Codefodder. So this is Thomas Tassin and Pierre Biesemans. You can check out their website if you ever have an idea to create something similar. They're actually experts in developing custom-made web platforms, and I think the OMD is a very nice yeah, it really shows what they can do and how good they can make the user interface. So yeah, I'm very happy to have worked with them on this project. We also already published an article in Journal of Membrane Science on the OMD. So please, if you're ever using the OMD, if you're using the data to benchmark your own membrane performance or to do any meta-analysis, please cite this paper. It was also very highly downloaded, I think in the top 10 of the most downloaded papers of JMS around the time that we published it. So there's definitely an interest from the field about this project, but as I will tell you in a couple of slides, there are also some hurdles that we're facing with the sustainability of the database. So the state of the art versus the OMD. Why is it so useful to have this OMD? Well, if we look at data features for the status quo and the OMD, then we see large differences. So what is the status quo? Those are actually reviews that are being published, let's say 1 to 2 years or sometime every 5 years, where the field is updated on what the status quo, what the state of the art is at that time. However, the OMD is real time, so you can upload your membrane data whenever you want, preferably directly when you publish it. So the update frequency is much, much higher. Also, we decided to source the data from the entire field, the entire reverse osmosis field for the OMD, while often when you look at literature, the reviews, they, for example, only include polyamide membranes or they only look at commercial membranes. So the scope is much more limited than for the OMD. Also, the processing of the data might be variable for the reviews because you sometimes don't really know if they included, for example, concentration polarization or if they left out certain testing conditions. For example, if they only use dead end or only use cross flow, sometimes that's not really clear. And it's also difficult then to compare it if you don't know. Well, for the OMD, that's completely uniform and very transparent. I think that's also something really important that is just more transparent than how it is done now in the status quo in our field. Also, in these reviews, it's just a PDF file, right? So you cannot do anything with the data because it's not interactive at all. Well, for the OMD, as I will show you, you can do many things with the data. It's a very interactive way of exploring data and then do interesting things with it. Also, the accessibility of the data for reviews, it's only available upon request. You need to contact the author. Often you don't get any response. It's also very inefficient, ineffective to do it this way and often without success actually. While for the OMD, you can just download all the data that is on there. So what can the OMD do? How can it help us? How it can help you? And how can it help the field of membrane technology and membrane science? Well, it can help us to benchmark novel reverse osmosis membranes that are being synthesized in the lab against the state of the art. We can also use the data to conduct meta-analyses. And very importantly, we could use the data to finally develop and better understand the membrane synthesis structure performance relationships to really push the field forward in terms of knowledge discovery and membrane innovation and design. We've also incorporated right now, actually just yesterday we launched it, we put it online, the calculators that we've developed to calculate online membrane performance, concentration polarization, and osmotic pressure. And then I think the OMD could also be a good hub to facilitate interdisciplinary research. I think we've seen that over the past 10 years probably, that there are people from many different fields of science gathering together in our field, and some of us don't have the same, don't start from the same knowledge. And so I think it's very, a nice way to get the knowledge out, to just, say with open arms, this is a field where you can maybe actually contribute. So to summarize, I think it can actually really advance the field of membrane technology and science, not only in knowledge discovery, but really also to develop novel materials that can actually happen, help to combat the global water crisis. So a bit more specifically about the OMD, about the data, the origins, and the constraints. So as I told you before, we gathered data from peer-reviewed literature, from commercial data sheets, and from patents. And from at the time that we launched the OMD, about 60% was from scientific peer-reviewed reports, so articles. Patents were about 30%, and 8% was was coming from commercial data sheets. The information that we require on a membrane, it's quite a lot. So we want information on membrane chemistry, on the synthesis of the membrane, also on the experimental conditions, and this is really an important point. Also the physical characteristics of the membrane, and also the membrane performance, obviously, because that is in the end the core of the database. I do want to come back on these experimental conditions, but because that is actually one of the big hurdles, I think, in comparing membrane performance. So I'll come back to that in a second. We defined a reverse osmosis membrane, because the OMD is only focusing on reverse osmosis at this moment, as a real rejection of sodium chloride above 80%. So we had to set the limit at some point. Some people do it at 90%. We decided to put it at 80%. So this is arbitrary, but I think it's important that you know. However, there are some exceptions, because we want the OMD to encompass as much data as possible. So for example, if a researcher has synthesized systematically a set of membranes, for example, via layer by layer technology, or if they systematically altered the polyamide layer with a chlorine treatment, for example, and you have a performance of 40% or a rejection of 40, 60, 80, 95% rejection, then actually we have included the whole series, because we thought that it would be very helpful actually to have all the amount of data, so that then actually you can then see trends and do the meta-analysis on the synthesis structure performance relationship. There's also some data on FO membranes in there, just to have more and more data, because it's actually really important if you want to do statistical analyses or even machine learning. Also, it's important to know that we are not looking for the best performing membranes. We really want all the membranes with reverse osmosis performance in there. The more data we have, the better it is, really. So it's really as much as as long as they follow the initial constraints, then it's good enough, and the membranes should be on there. So I hope that this is really welcoming to many people. It's not because you don't have a 99.9% sodium chloride rejective membrane that you should not upload it, because it's actually by uploading more and more membranes that we will actually see trends. So a bit more into detail about the membranes itself. So we have 4 categories. So integrally skinned asymmetric membranes. Then we have the most prevalent one, thin film composite membranes, TFC. Then we also included thin film nanocomposite membranes, which have nanomaterials in the thin top layer of the TFC. So we call these TFN membranes. And then we also have inorganic membranes. So for example, carbon nanotubes or MOFs or other inorganic materials. The information that we require on the membrane and how it was tested is depicted here. So as I mentioned before, we do require information on concentration polarization, because it actually really alters the membrane performance. We also want some information on the solution chemistry, so the pH of the feed solution, also which concentration of salt you've used, also if there were any other solutes and sodium chloride present. We also want some information on the physical characteristics, so for example, contact angle and roughness, but these properties are not mandatory, so you can add them if you have the data to the database, but this is just, it's not mandatory. Also the post-treatment, so for example, if you've cured your membranes in an oven, or if you've added a solvent to it to make them more permeable, for example, you also need to give us that information. Obviously, membrane chemistry, very important. And then also whether there were synthesis modifications, for example, if you have added different monomers to it, or if you have added just additives or something else that modified the synthesis. And then all of that is on the membrane itself. And then obviously the performance characteristics is really important. And we have decided to always include A and B values because these actually give you information on the intrinsic membrane properties. A note on membrane performance. So the required information for the OMD is A, so water permeability coefficient, B, salt permeability coefficient, A over B you can then calculate from A and B, and then real rejection and observed rejection. However, in almost all the articles that we've inputted in the OMD, we only saw water flux and observed rejection. And so the problem is that these properties are operational dependent, so you cannot compare membrane performance by just looking at observed rejection and water flux. So that is why we had to convert these values into A and B parameters, because these are not operationally dependent. But the challenge with it is that you need to account for concentration polarization, and then it actually becomes quite tricky. However, we decided to do that because we do believe that in the end it's about the membrane, and you also should take into consideration the way it was tested. So that is why I also want to explain this to you in a bit more detail, without going too much into detail, but just so that you get the basic idea. So concentration polarization is a formation of a polarized layer because there is an accumulation of the solutes that the membrane is rejecting exactly at the membrane surface. And because of that, the driving pressure decreases and the overall membrane performance decreases. So you can quantify concentration polarization by the concentration polarization modulus, which is the concentration of the solute at the membrane surface, divided by the concentration of the solute in the feed, in the bulk. And so if you want to characterize this, you need to have the Kf value. And the Kf value is the mass transfer coefficient. You also need to have this Kf value if you actually want to calculate A and B. So I've depicted here the equations again, just to refresh your memory. Or if you're seeing this for the first time, then you actually now see that this mass transfer coefficient is an important parameter to determine the A and B intrinsic membrane performance parameters. As I told you before, and that actually was the case for, I think, 96% of all the membrane data that was uploaded to the OMD. We had to assume the Kf to be 100 because there was just no information on it. So we calculated A and B values for all the literature that we gathered together, assuming that the Kf was 100. We do understand that some people will have objections against this because it's still an assumption and it's not reality probably, but our reasoning behind it is that it's still better to at least account for it a little bit than to not account for it at all. But right now, we have to facilitate this process of calculating Kf and to have an idea about how bad the concentration polarization is in the system you're using. We have put online these OMD calculators to actually calculate the concentration polarization modulus and also the mass transfer coefficient for all different test systems. So for dead end, cross-flow stirred cell, and then the different turbulence conditions that you can have. So when we look at the functionality of the OMD, so now I'm sharing some screenshots, but I will directly move on to the actual website. So we have added a lot of filters, so you can see all the filters here in the drop-down menu on the left. It's a very interactive chart, so you can hover over it, and then there are data callouts when you hover over the data points. You can also, there's actually a table on the bottom that is giving you all the information that we've inputted, and then you can export that data in a CSV file and then do the analysis yourself in Excel, for example. You can also export the figure and then use the figure directly for your own convenience. There is also a big part of the OMD is user submissions, so the user submission form that we've created. So you need to enter the information on the report and the data itself. You can then provide contact information about yourself. And then we've also, we try to make it as user-friendly as possible because we understand that you need to, dedicate some time to it. So at least we try to, do it as good as possible. And so, for example, if you have one article with 10 membranes in it, then you have to go through all of this, all the different steps for one membrane, but then you can just copy it and just change the parameters that have changed for the other membrane in the article so that you're winning some time. So it's really a step-by-step process. It's user friendly, but it still takes some time. And then we also review the submission in the back office. The OMD team is taking care of that, and then we launch it online. As I mentioned before, we have also developed 4 calculators, well, actually 3 calculators and just a common unit converter. So the membrane performance calculator, the concentration polarization calculator, and the osmotic pressure calculator. So these are actually just tools that we put online to help the users. It's actually not so easy to calculate all these values if you don't have a lot of experience or if your lab is not experienced in it. And especially for determining the membrane performance and the effective concentration polarization, we thought that this would really help people. So now I will move on and share the actual database. So I hope this worked fine. So this is the home page where you see different tabs here. So the database itself, some basic information about membrane science and technology. So this is really for the people who are not familiar with the terms we're using. Also, we put some information on the standardization of membrane performance testing. We're still working on that. And then also some extra information on concentration polarization, why it's actually so important to include that in the analyses. Then we have the different calculators here, and then a news tab, an about tab, about who we are, why we did this. And then this is a very important button that I hope all of you will click on soon. But let's first go to the RO database. So you can see that there are 662 membranes in the OMD data set right now. So here you have all the things, all the parameters you can change in the graph. And more below, you have the tabulated version of the graph. And these two are actually connected. So this is the graph with A over B as a function of A. And then you can actually manipulate the data. So you can set filters. So for example, if we're interested in membrane structure and we're only interested in polymeric thin film composite membranes, then you see that we went down from 662 to 612. And so the filter is applied, meaning that only these membranes are here now. You can add multiple filters at the same time. So if you're, for example, only interested in membranes that were tested in crossflow, then you can add that as well. And then you can see the number decreasing here because of the additional filter that you've applied. You can also plot different things, so always as a function of A, but you can decide to plot A over B, observed rejection, and also real rejection. And then you can see the plot changing automatically when you click on it. You can also decide to have a log-log scale, so a fully logarithmic scale, or you can decide to do a linear semi-log plot or a fully linear plot. That is just whatever you want to do with it, you just decide. And then you can also change the chart legend. So this is here, the chart legend. We have opted for 3 possibilities. So selective layer chemistry, membrane structure, and also, so let's click on that, for example. But because we have applied this filter here, we only see polymeric TFC. So if we click that away, then we see that it automatically updates to all the different categories that I've explained to you before. You can also have the chart legend as report year, and then you see all the different articles when they were published, changing with the color. This is just layout, so you can decide between rectangle, square, or full width, whatever is more convenient for you. I personally prefer the rectangle version. So if we then look here, you see when you hover over all the data points, you actually get the information. So for example, this membrane is called TFC MPD, was released in the year 2017, and then you have the actual raw data right there. Also the chemistry we've included in the callout menu. When you go over this graph, you actually see these little buttons here. So download plot as a PNG. So if you click on this, then you can directly just save it to your computer. And also you can save it with the filters on, of course. So this is not only giving you all the data there, but this is also really with the filters. You can also zoom. You can also pan. So those are all the different functionalities that we've included. And then importantly, you can also select some data. So this is with the box select. And if you do this, then these data points are selected. And then these data points here, the 21 data points that I've now selected with the box select, are then also depicted here in the tabulated version. So if we look a bit in more detail to the table, then we see many different columns. So author, year, reference, title, and then all the different properties of the membrane. You can also add columns here. So we've decided to release all the information that we've inputted. So if you click on all of them, yeah, all the columns will appear. You can also order them or sort them. So now you're sorting by A up and A down. You can do that for all the different columns. And here there's also a column on concentration polarization information. So this is what I've told you before. So for example, for this membrane, we calculated the A and the B values based on the observed rejection by assuming a mass transfer coefficient of 100. And if you would go through all the data, then you will see that we actually had to do that very often because those details were not shared in the article. When you click away the highlight mode, so this is just by a double click, and you go back to home, then all the axes are being reset, and then all the data is present here. And then you can decide to export this as a CSV file. Then you can save the file and then import it in Excel. So that is what I've done here. And then you can just do all the meta-analysis, whatever you want to do with the data. You have all the data here. So I think that's a very nice way of sharing data with people, and hopefully get some knowledge out of it, some knowledge discovery that we can do with this. Then I would like to show you how you can submit a membrane. So you click on this button. Then you can first look if the report is already in the database. So if it's not, then you need to add a membrane from a new report. Then you add the DOI. I'm just doing something as a test. Oops. As a test here. Seems like my... Okay. And all the fields with a red asterisk mean that the field is required. You see that on some input fields, you just have to input it yourself. But for some fields, we have already pre-inputted the different possibilities you have. So to just keep it simple. And then you can see all the different information that we need from you. So let's say we are inserting a polyamide membrane. Sometimes you can have different chemistry, so you can add multiple here. We also require you to input whether you modified the membrane or not. So if you didn't do that, you just put no modification, but we've already given some examples here. So for example, maybe you have done some solvent activation with DMF to make the membrane more permeable, then you can also add that information here. The structure is also in a drop-down menu, so the structures I've shared with you before. And then here is then the test information that we require. And so this is actually really important. So here you have A value, B value, A over B, real rejection, observed rejection, and then the diffusive water and salt permeabilities. So let's just input something. Then you see that this is directly calculated by the website itself. I just want to quickly do this. So again, here is an information button. If you click on it, and then the calculator will actually directly open, and you will be able to do the calculations yourself. I will come back to that in an instant. Just one last thing that I would like to show you. So these are all the input fields. I know it's a lot, but without that information, we really cannot say any meaningful things. Also other solutes, we've decided to incorporate this option as well, because sometimes people are testing sodium chloride rejection, but then they also add boron or isopropanol or any other solute, and that might actually influence the overall membrane rejection. So that's important to know for people who are doing meta-analysis. And these are then membrane characterization data. So this is more physical-chemical properties of the membrane. So these are also not mandatory, but if you have calculated them in your research, then you can add them here. And then we've also added the possibility to say which characterization data is in the article. So for example, if people are doing a study on AFM, on the roughness of a membrane, then they can search for AFM in the table, and then they can actually use that data. So these are then the contact information and additional details that you can insert. But what I wanted to show you here is that you then have an overview of everything that you have inserted, of all the data that you provided to the OMD, so you can just check whether that's correct. And then you can submit it, and then the OMD team will analyze it, see if the values are correct, and then we will launch it online, and then your membranes can be used also by other researchers. So then the last part that I want to show you here on the website are the calculators. So we have 4 now: membrane performance calculator, concentration polarization calculator, osmotic pressure calculator, and then just common unit converters. This is maybe a bit silly, but on the other hand also handy to bridge the gap between the imperial system and the metric system. So membrane performance, I won't go through all of this right now. I think it's it explains itself actually. And if it doesn't, then you should contact me, because we've really decided to make it as user-friendly as possible. We also designed it in such a way that these are actually how you should also do the tests in the lab, in the order in which the test should be done. So this is water permeability coefficient, pure water permeability coefficient. So let's quickly, just to give you an example, then you see that the output value is A. So these are always the input values, I, double I, triple I, and then the output is always below the line. Same you can do for observed rejection. You just input the values, and then the calculator calculates it automatically. Please mind the units though, because for this example it's now maybe not so important, but for here please mind the units throughout all of the calculations, because if you don't take care of that, then there's nothing really we can do. Also, solute flux you can calculate, solute permeability coefficient, and then the real rejection, also water salt perm selectivity. And if you're really into it, then you can also calculate the diffusive water and solute permeabilities by taking into account the membrane active layer thickness. So you can, these calculators are just, they're online. Everyone can use them, also for people who are not uploading data to the database, but it would be very nice if you would use them and then also upload your data, of course. The last part I want to show you is here the concentration polarization calculator. So I think for many people in our field, this is really a hurdle. We don't really know how to do it. It's also not easy, honestly. It has taken us quite some time to figure out how we could explain this to the users as easy as possible. So we've opted for this design. So this is the concentration polarization modulus, where you need to insert the observed rejection, the water flux, and then the very important feed side mass transfer coefficient, the Kf. And so this is often a parameter that we don't know. And you need to calculate that with kind of complicated calculations with a lot of information that you need from your system. And so here we have also provided you with the different equations that you can use. So this is in cross-flow, this is in a stirred cell, and then when you expand the sections, you have laminar flow, turbulent flow, and then also when you expand in that section, you have all the different testing conditions that you should check to know which equation you should use. So then you need to add the flow rate and then all the other parameters, and then the calculator will give you the Kf value in 2 different units, depending on which equations you want to use for your own research. So that is everything I want to show you about the OMD website itself. Please don't forget this button. I hope you'll start using it soon. Then let me get back to my presentation. So the last part is about expanding and extending the OMD. So a big important thing that I want to share with you, which is a bit sad for me and for the whole OMD team, is that we didn't have any external submissions since August 2021 when we've launched the OMD. So that means that there was, that we have inputted all the data into the OMD, but no other researchers has given us their data yet. So there's an urgent need for more submissions, and it's actually really important to upload the data because otherwise it's impossible for us to sustain the database. And also actually even for meta-analyses and for machine learning and statistical analyses, we really need more data to allow meaningful conclusions. Because the more data, the better. That's really how you should look at it. So how can we get there? Well, actually, all of you, I hope many of you who are listening right now would be willing to give us an hour and a half, maybe 2 hours of your time to input the data from articles that you've already published and that are online to the database. We are also thinking of building a membrane repository that is linked to an article submission. So when you're submitting your article to a journal, then you should also input the raw data into what we call membrane repository. And then once the article is accepted for publication, then the data is transferred to the OMD. And in that way, we would automatically feed the OMD every time a new article is published. So we're trying to figure out how we can make that work. This needs a lot of logistics. It's also not so easy to convince journals, but would also be good if there are other people who would want to work on this with us, or even just if you have any ideas of how we can motivate people to input data into the OMD, that would be great. We are also now working on expanding the OMD by highlighting the membranes that are tested under standard conditions. We really think it would be good to define a set of parameters under which you should test the membranes to achieve, let's say, a gold standard for membrane performance testing. And then these membranes then we're sure at least that there are no operational fallacies that can change the ultimate membrane performance. We also would like to include the trace organic contaminants, so not only sodium chloride, but also these contaminants which are posing an increasing environmental threat to our ecosystems. And then we would also like to include a dynamic upper bound, so a bound that is an upper bound line that is actually shifting depending on which data points you've collected or selected, which filters you've applied. We think that that would also be very useful for the field. And then something else that I've been talking about with some other people who are more in the process design world, it would also be very helpful, I think, to use the data that we have in the OMD to feed process design tools. So for example, ProSyn has been launched as an online tool to calculate that. And I think it's a nice way that the membranes that are present in the database can then be used to see if they would be useful for a certain separation that is needed in industry. I think that's also a nice way of bridging the gap between academia and industry. And then extending the scope of the OMD to other membrane technologies. So I was at the OSN SRNF conference a couple of months ago in France. And there we saw that it's also really important to standardize the testing protocols to allow cross-comparison of different membrane systems. Also in this field, it's really important to be more transparent about our data, how the data was collected, etc. And so I've launched there the idea to also create an open membrane database for solvent-resistant nanofiltration and organic solvent nanofiltration. Professor Zekeli from KAUST has already been working on this, but from a completely different angle. I would also suggest you to check out that website if you don't know it yet. And it would be really great if we could combine the two databases together and create a new one. And then there are, of course, also other membrane technologies which would lean themselves very well for a database, such as ion exchange membranes, nanofiltration, forward osmosis, and electrodialysis. But of course, a lot of work is needed to make a database like this. This actually all started as a side project and then grew bigger and bigger. So collaborations and cooperations on this would be very much appreciated. So this is almost the end of my talk. I think it's the main message I want to get across is that we need to sustain the database, and we cannot do it if the field is not supporting this initiative. So please, if you would have some time, please submit your membranes, talk about the OMD. If you want to get involved, contact me. I'm always very happy to work with new people and to see this project thrive. but it's really important to get that support from the field. So the acknowledgements, really, it has been a long ride, but a very, very nice ride, supported by many different people and many different universities. As I mentioned before, KU Leuven, Yale, Technion, and Hong Kong University. Also a lot of funding agencies that are depicted here. And then I would like to explicitly also thank again the European Membrane Society for giving me the opportunity to showcase the OMD here today. And then also the Membrane Society of Australasia and African Membrane Society, who have been willing to support this initiative and endorse it. So please spread the word about the OMD. I hope I could convince you of the benefits of it. And please reach out to me if you have any questions, any ideas. I would be very happy to take on new people on the team and brainstorm on how we can make this a sustainable database that will help our field forward. Thank you very much for listening.
Thank you, Rhea, for this very interesting presentation. So, of course, I now encourage the audience to ask some questions in the chat. I have a question. Okay, is it possible to introduce FE forward osmosis data as well?
Excuse me?
Salute Camilleri is asking whether it would be possible to introduce FO data as well.
Yes, it's possible.
Okay, you mentioned that at the end of your presentation.
Mm-hmm.
I have a question. How would you check the validity of the data that are uploaded by the user? Would you ask for, I don't know, a linked publication that can ensure that the data have undergone a peer review process?
Yes. So that is really one of the important aspects of the database. We do not include any data that has not been peer reviewed.
Okay.
So the article should be published and accepted online. So as long as it's not accepted by the journal itself, we do not accept it.
Yeah, that's very important. And another thing that I noticed, you mentioned in your presentation that you use sometimes assumptions, for instance, on the value of KF. Will that be a problem, for instance, if I use your data for a machine learning based approach?
Yeah, so this is a tricky question and something we've been struggling with as well. So either we include it or we don't. You have to assume a value for KF if you want to say anything about A and B values and real rejection. And yeah, our reasoning was that we cannot compare so many different membranes if we have to take into account the operational conditions. So to get rid of those, we decided to then work with A, B, and R real. And yeah, for that, you just need the KF. So if it's not provided, if it hasn't been calculated, then we just had to assume it. So it's not ideal. In the ideal case, everyone would always report the KF, would always know the exact dimensions, the exact conditions of the systems they're working with. But because that's just not possible, it's not standard practice in our field, we thought that it would still be better to make an assumption.
And is it possible to filter out the data? Okay.
Yeah, that's definitely possible. So maybe I haven't highlighted that enough while I was going through the website, or when you would do the data analysis for meta-analysis, for example, or for machine learning. So please be careful with the data that you are inputting in your algorithms. So you can really filter out the data that you don't need. So for example, still don't start comparing dead end with crossflow, for example. You should please be aware of what you're doing. We are giving you all the information, but that doesn't mean that you should just take all of them. I mean, you can do it if you know what you're doing, but still some common reasoning should be there. Even then. Okay,
thank you. Do you see the question from?
No, actually, I'm wondering if I should stop sharing my screen.
Yeah, maybe yes, so that you can look at the questions on the screen.
So the data from patents, also a really good point. So we decided to include the data because we wanted to bridge the gap between academia and industry. We have added this as an extra filter, so you can filter out the patent data because, as it's probably why you're asking this question, it has not been peer-reviewed patent data. So that is actually posing a threat to the OMD for the validity of the data, but you can sort them out. So that is a good thing, that you can choose whether you're only interested in commercial product data, in patents, or in scientific reports.
Okay, very good.
Yes, yeah, so it's possible. You can actually also filter on that. If you would export the graph into the tables into a CSV file, then you will see it in your Excel, how often it was approximated with the assumption of a KF of 100. But I'll tell you already now, this was for, I think, 95% of the membranes the
Okay.
case.
The vast majority.
Yes.
Okay, while we wait for other questions, let me remind you that we normally host a seminar every first Wednesday of the month. So we'll keep you updated on the EMS website. Also, I ask you again to subscribe to this channel in order to expand our community and the outreach of our activities. But I see no further questions. So if there are no other questions, then I would like to thank you very much, Rhea, for this initiative and also for the talk on behalf of all the European Membrane Society community. And good luck with your
Thank you so
initiative.
much. Thank you so
Bye
much.
bye. Have a nice
Bye-bye.
afternoon. Bye.
Thank you, you too. Bye.